So our next speaker is Dr. Fredrik Gröndahl, who's been with KTH since 1991. Fredrik's research is focused on nutrient flows in the Baltic Sea, ecological engineering methods, and wastewater treatment in Antarctica. For the past several years, he's focused on the usage of algae and other marine substrates for bioenergy production. He also works with development of various international courses and basic courses and master's courses at an industrial ecology at KTH. He has also done work with the production of textbooks in environmental sciences and sustainable development. Today he's going to talk about his research in algae and on the SEAFARM project that he's heading for KTH. So with that, Fredrik, I'll turn it over to you.
Thank you. Okay. Well, if you come to Stockholm, you should go and visit the king. He lives in that big house there. We have a king and a queen. Okay, as you said, Fredrik Gröndahl is my name, and I will present a project that we have just started. And last time we were here in February, I was talking about a project called Submariner. That was the project named Sustainable Use of Baltic Marine Resources, and that was a European Union project. And from ideas in that project, we applied for a project in Sweden, and where we were focusing now on macroalgae. And we got funded now just before summer holidays, and the project had just started, so we are really just starting, and it will be a 5-year project from now and onwards, and it's relatively, for Swedish conditions, quite a big project. And the acronym for the project is SEAFARM, and this is Seaweeds for a Biobased Society, farming, biorefining, and energy production. So it's really taking a holistic approach, and there is a multidisciplinary project with many people involved from different disciplines and different universities also. But for the people that don't know Scandinavia so much, now you know where Stockholm is and you know where the king lives, but there is more to Sweden. Sweden is a relatively big country. It's one of the biggest in Europe actually, size-wise. And we have a sea here called the Baltic Sea, and it's a brackish water. It's the biggest body of brackish water in the world, so it's kind of unique, and it's also one of the most polluted seas. It's more than 90 million people living around the Baltic Sea, and it's a lot of pollutants coming out here. There is problems with eutrophication, there is problem with organic pollutants, there's problems sometimes with oil, accidents and things like that. And as you could see, we have our neighbors here, Russia, Estonia, Latvia, Lithuania and Poland that are under development, and there have been a lot of pollutants coming from here, but also of course from Scandinavia, forest industry in former days. So there's a lot to do here in the Baltic Sea. It is a brackish water environment, and then you come into the Kattegat here, it's getting a more saline, and then you go to the Skagerrak where you have an Atlantic water, so there you are definitely in a marine environment. The project I will talk about today is located not in Stockholm at KTH, it's located there up in the northern part of the west coast of Sweden, and it's in this area, and here we have the most marine situation along the whole Swedish coast, and here we would like to start the SEAFARM and work with the algae. So Europe have some ideas on how to continue to get growth and get the economy going. And now they have had new funds opening up that is called Horizon 2020. And if you read these papers, you see that something that is really an European Union priority is the so-called bioeconomy. Building a sustainable bioeconomy for Europe. So that is the key issue, and that will also create growth. And that will be smart growth, sustainable growth, and an inclusive growth, a broad-based growth. And it will be combined with innovation. So it's innovation, turning innovative ideas into products, a process for growth and job creation. And if you look into this, where is this going to happen? Is it on land, or is it in on land in the agricultural sector, or is it in the cities, or is it in the forest? No, they believe actually that this will happen in the sea, that we are going to create this growth in the coastal region and utilizing the resources that we have in the sea. So if you look into this strategy, there is this idea is called blue growth, and you look into it is increase of tourism in the coastal region. How is that going to be done in a sustainable way? That is an important part. It is more transportation on the sea, to have more transportation along the sea. It's aquaculture, and that's what we come into now, aquaculture, and that is for fish, algae, mussels, etc. So these are things. So what we are doing now is to look on the sea and how are we going to manage the sea in a good way. And we are starting farming, you could say, at sea. Not just on land, but also starting farms at sea. And that will also mean that we are starting to allocate surface space in the sea as industrial areas in the sea. So that is very big now in European waters, that you start with a sea planning, dividing the sea. Here is good with offshore wind farms. Here we could have wave energy. Here we could have aquaculture, and we could combine it. So these kind of initiatives are now taking place. So growth, at least according to the European Union strategy, will take place in the sea during the coming 6-7 years, when they are sending out 80 billion euros into research around this. So it's a huge amount of investment taking place here. Okay, then you have to have the lessons, because you want to increase things in the coastal regions that already have big problems. I mean, there is a problem. I told you about the Baltic Sea. We had eutrophication, we have the pollutants, we have all these problems. And this is, now we are going to do it in the Mediterranean. This is not the Mediterranean, but sometimes it looks like this on the coast of the Riviera or in the Italy or around the Mediterranean seas. But this is from China. You could see here a huge amount of people crowded, and there is eutrophication problem and intensive blooms of green algae in this case. So this is of course not the future we would like when we increase the activities in the coastal region. So we have to do this in a sustainable way. And this is the critical issue. It's not just growth. It has to be regulated, and it has to be a smart growth. So let's go in now and talk a little bit more about SEAFARMs that will connect things from this in this strategical project. It's actually a strategical Swedish project that have been initiated. And involved in this, there is 4 or 5 universities, you could say, but it's Gothenburg University that is located on the west coast of Sweden, close to where the site will be for the SEAFARM. Chalmers University, that is the second technical university in Sweden, so that is also located in Göteborg, where we have the knowledge about industrial biotechnology and food science. Then we have our own university here. We have the Department of Industrial Ecology, that also is the project leader, and we have the fiber and polymer technology on the chemistry school at our university. We also have the Linnaeus University, where they have bioenergy knowledge, and especially on biogas that we are very interested in. So the knowledge is from there. And then we have Lund University that are incorporated actually in KTH here, where we have the Department of Economics. They are doing economics around environmental economics, and have been doing this for a long time. So there is a good knowledge there. So it's a multi-university approach from the whole country actually in the project. But it's just a national project. There's no European Union involved in this. It's a Swedish project. And then we have a number of partners also. So we have the university, but around the project we have regions. And we have this region, it's the West Coast region. We have the region of the East Coast. We have municipalities. And we have a number of different companies. This Pauli group is a big food company that Santa Maria, I don't know if you know that, but it's a big food company. We have plastic and chemical federations with a lot of different companies here. We have people working with companies working with biogas, etc. So there is a tight cooperation with industrial partners and also municipalities that want to develop this in the region. Well, the budget, I mean, from a Swedish side, it's a big project and it's a big ambition. So we got from the Swedish Research Fund, we got 25 million crowns, and then the partners contribute with an additional 6 million crowns. So the total budget is about 31 million Swedish crowns, and that is about $5 million, the project. In Sweden, this is a relatively large research project. Normally, but it's also for 5 years. And it will be a hub, you could say, that will generate additional projects around it. So it's kind of exciting the way it's organized. So that's a little bit about the project that have started. It's multidisciplinary. There is a lot of different partners. And the thing is that during 5 years, we should try to solve all the things that in the end, finally, could establish this concept in one of the regions in Sweden here. So let's start here from the beginning with aquaculture. And why this is an important part of blue growth. And this is capture production. This is actually wild caught things. But you could see that there is a dramatic increase in aquaculture. And it's actually going faster and faster. So it's very soon the aquaculture will produce more fish and seafood than we have out in the wild. So that is a big difference taking place. And of course, this is convenient. This is convenient in many ways because it's practical and so on, but it doesn't necessarily is sustainable. This is a bit why we are behind, you could say, when we talk about aquaculture. Europe is behind, and also, I mean, in a way, North America, South America, and Africa, all are behind. I mean, China here is huge, so you could see how important they have been doing this for 2,000 years. So they know how to integrate aquaculture into systems and use it. And also, of course, other part of Asia, excluding China, but this is huge, big. Here it's mostly for food production, but in Europe, the one country that is big on this is Norway, and to some part also Scotland, but Norway is really huge on this in the European, and that's our Scandinavian partner. So we want to increase aquaculture. That is something that we would like to do in a project like this, and use the unique conditions that we have in the Swedish waters. And what we are going to focus on in this trial here is going to be a culture of seaweeds or kelp. And this is brown algae. This species is called Saccharina latissima, and it's an Atlantic species. It likes a bit colder waters, and it grows very fast. I mean, it grows in a couple of months. It goes from very tiny to could be 7 meters tall, long. And it is also suitable because it has a lot of valuable chemicals in it, and you could extract a lot of interesting things. And it's also a good substrate for biogas, for energy. So it's a very interesting species. And we have been looking at a system that I have developed in Scotland, and we are going to apply this system in Swedish waters. So this is quite easy in that sense that we have the seeding, so that the algae will release spores into the water, and they will settle on this line, and there will be small tiny plants here, and this you do in the laboratory, and then you place it out in the sea, and when it comes out in the sea, it will start a very rapid growth, and then you could make a harvest, and then you could continue like this. The thing is that when you put them out, you could harvest them in about 4 to 5 months. So it's a very rapid growth when it really starts. And that means also that we don't need to have these cultures out during winter time, because in Sweden it could sometimes be very cold, and we could go get ice on the sea too. So that could complicate things. But we don't need to have that here. And here we have the whole concept of SEAFARM. So it starts with the cultivation, and I just give you a brief how this is done with the Saccharina latissima. And then we have biomass. And the biomass have to be treated in some way. So we have to put in research here how to do this in the smartest and less expensive way. And also how to store it and preserve it and treat it. So we have a focus area 1 here, where Gothenburg University is involved. And then we have a focus area 2, where Chalmers are involved in this stage. And then we have the biomass go this way to what we call a biorefinery. And the biorefinery is for the moment located at the universities, on the laboratories at the university. And here we will screen the biomass for different types of food and feed additives. So we go in to look for different types of lipids, different types of carbohydrates, etc. And we will look for polymers and other biochemicals. And there is an array of useful things in this algae that could be extracted. And some of these products have a very high value on the market and could be sold for quite a substantial price. I mean, some of these substances could cost a lot. And then we will have a residue here from the biorefinery, and that will be extracted for biogas, and we will have energy out of it. But this is just a secondary thing, that we will use everything from this biomass. And then even here, there may be some nitrogen or phosphorus that could be used as a fertilizer. And then eventually it will leak out on the agricultural land or out in the nature again. And as you know, everything leaks out in the sea eventually. But since we have the farm in the water and we have a culture here, we could count the molecules, and then it will be taken up again, and we are closing the loop here. This will be evaluated, and this is the area where industrial ecology is mostly involved here in the focus area 5, and that is that we will look for the biomass potential, different technology, economy, socioeconomic aspects, and also the environmental aspects of the culture and all this cycle. And this is of course a very important thing, that we have this sustainability assessment in the same time as we are rolling out the project. So this is the whole concept, you could say. And for the first time, I would say, at least for me, it is a project that have all this in one project. Normally you maybe get the project here working with the culturing, or maybe you get the project working with some biorefinery thing here. But now we link everything together in a whole concept. And this is kind of interesting. If we will succeed, that is another thing. The aquaculture is interesting, and we want to develop that also. We want to, since there will be a limited amount of space in our archipelago, in our coastal waters, and we cannot have sea farms or algae culture everywhere. So as I said, we have this sea planning, and then there will be allocated areas for industrial use, you could say, if we now could call this industry. And aquaculture will be combined, and that is the nice thing, that suddenly we could have fish farm without worrying about the eutrophication effect from the fish farms, because if we combine that with a mussel farm that is very suitable waters in Scandinavian or in Swedish waters, and then you also have the seaweeds, the algae, then they will take care of the nutrients here, and you could have a production of fish, of mussel, of algae, and even you could produce things on the bottom where you could have deposit feeding animals that feeds here, crayfish, for example. So this integrated multitrophic aquaculture system is something that will be tested in an extended project now in the SEAFARM, where especially with the combination with the fish farm. And then we have also looking into ideas to combine these aquaculture areas with other things. And the most suitable could be combination of offshore wind farm. We could do that because that is something that is quite big in our waters now, that you establish wind farms. And then you could have macroalgae cultivation, mussel cultivation, fish farm, etc. Microalgae is down here. This is a little bit of a reality of this vision, and macroalgae is quite easy to have here, and also mussel, because it's kind of suitable in these wind parks. So the sea area will be used in many ways, not only one way. It will be a combination of activities taking place here. Okay, why are we doing this? I mean, we could do it for food and feed additives. I mean, that's nice. And there is very few biomass that you could get food, you could get feed, you could get chemicals, you get energy. It's very nice. I mean, oil, okay, you could get energy and you could get chemicals, but you don't eat oil, not so much. But this is good also for food, and that makes it a very special and nice biomass. And then, of course, we could do this blue biotechnology that is a part of this. And the oceans cover, I mean, 70% of the Earth's surface. It's the 90% of the habitable space on the planet. And about 50 to 80% of all life on Earth is found under the ocean. And there is more than 3 billion years of knowledge how to survive on this planet. And when it concerns marine microorganisms and marine organisms, there is a very, very small, tiny proportion of them that have been discovered even. So to look into the sea and to see what's in there and how we could use this organism for different things is a big issue in the blue growth ideas. And algae are of a very special interest. There is a tremendous biodiversity in the sea, and it's just we have to start to take care of it in a proper way. And this is a big market. The global market for this marine biotechnology products is about 2010, 3 billion euros, and it will increase rapidly. So there is a big potential in this. And what could you use these things for? I mean, you could make medicines, of course. You could use it for animal health, cosmetics. And you see you have macroalgae here. If you extract a valuable compound from a macroalgae and then you make a cosmetic, you could sell it for a fortune, because this market you could really take, even if it doesn't work, you could charge quite a lot for it. So that is one example of a high price market. So that is incredible. And algae is coming into a lot of different creams and things like that. You get 10 years younger if you use macroalgae in your face. Yeah, you could. And it's already used in ice cream, and it could be feed for aquaculture. You could have it as an environmental project, as we have in sea farms. We have the farms in the water. It's taking up things that makes the water eutrophicated. We could make biofuels from both macroalgae. You could make biodiesel, but macroalgae you could make biogas, bioethanol, etc. So there is a number of things that could be done. And there's a high potential in the Scandinavian waters, actually, and this makes the Baltic Sea region. So, and then I could say one more part. So now we have looked on the aquaculture itself, and that it could produce food and feed additives, and that is one market. That we also could look into this biotechnology and see what kind of valuable chemicals that could get out that we could sell on the market. But then eventually we will have a residue that we could make energy, and this is biogas that we were thinking about. And this is a project that we've been working with before at our department. And I maybe showed this last time it was here. This is in the south of Sweden. And you could see huge masses of filamentous red algae in the coastal region here. It's really a soup of red algae. And this looks very much as the pictures from China that I started the talk with. You had this bloom of green algae. And when we did see this, we said, okay, this is a problem. And the problem is that we have a very eutrophicated Baltic Sea. And that is because we have a very big production of agricultural production here in the south of Sweden. It's like here in Illinois and the film we did see yesterday. I mean, it's the same problem. Coming out, creating dead zones in the area because it's a lot of organic things that make anoxic condition and dead bottoms. So we said this is a problem, but maybe it could also be a resource. So let's see if we just could harvest it, take it up, and make something out of it. And here we didn't take all these steps as we have thought about now in SEAFARM. We just wanted to get it up and get rid of it. And then we said we will do biogas of it. So we had our other PhD student, Emma, that have been working with this, Emma Rysén. And this is just one example in one little municipality in the south of Sweden, where harvesting about 10 to 30% of the algae on just a small coastal stretch of 40 kilometers. You could take up the algae, and then you could have remediation of nitrogen, for example, and that would be about 50 to 150 tons of nitrogen reduction. And that is about 5 to 15% of the annual freshwater runoff that comes out. So this is a better, from a eutrophication point of view, this kind of project is better than to establish a sewage treatment because it takes more of the nitrogen in this way. And then as a byproduct you get energy in form of biogas, and now we just transferred it to that 170 to 500 households that could be heated annually. So you could see here that is many positive things here. So the thing is, if this could be profitable, and that we have been doing a bit also at Industrial Ecology, we have been looking into the socioeconomical aspects of this. And try to, because to produce biogas is not profitable. Whenever you do it, it's not profitable. It costs more. You need to get the substrate for free, and then you could produce biogas. So that is not profitable. So you have to find other ways to convince people that this is good. And then this nitrogen reduction, but this is profitable, because it will improve the situation in the Baltic Sea. But the problematic thing is to put the value on this. How much is it worth that we reduce the nitrogen and get a less eutrophicated sea? Would it attract more tourists to this coastal area instead of swimming in this algae soup, stinking algae soup? They could have a better beach and have a nice swim instead. How many millions of crowns is that? So this kind of calculation and how to validate this is something that we are trying to do in our projects, because it's essential to find a good way to make a price on this process chain. And when you do this type of calculation, eventually you could find that some of these projects are actually something that is pay off, that is worthwhile to invest in. And in the case of the algae here in Trelleborg, there is kind of quite convincing data now showing that it's profitable to do it. So that's good. So we try to do this kind of calculation, so that's part of the work we are doing. And then we try to work in cooperation with economists, for example. Yeah, if you want to follow this project, if you think it's interesting, there will be a homepage. It will be launched maybe this week or at the beginning of next week. And it will be SEAFARM.se. And then you could follow the project and what the activities taking place there and what will be coming out from the project during the coming years. So you could look there. And then, yeah, these are the one founding it, the Swedish Research Council Formas, committed to excellence in research for sustainable development. That is the Research Council. That is. Okay, so thank you very much.
Thank you very much. We have time for a few questions.
Yeah, having worked on the ocean for a while and off the coast of New Jersey, I know any structures you put out in the ocean are going to attract all sorts of marine organisms. And I'm wondering with these, whether it's wind turbines or wave energy, if there's, you can get the engineers on those projects, design them to enhance potentially fish growth or fish harvesting around the structures.
Mm-hmm.
You've already talked about the algae that might grow there and some of the other organisms, but there's some real opportunities to have not only industrial development, but also to be able to harvest some of the biomass.
I mean, all these things we put out, I mean, wind farms or the fundaments there will be like artificial reefs, secondary reef structures that will attract more fish and things like that. And also the algae in themselves, when they are hanging there, could attract more fish. So, and this is part of the projects to validate the effect on the biodiversity and the possibility to get additional extras from this.
I was wondering, do you have much of a sport fishery there? I mean, charter boats going out to fish? Because sometimes that can add a lot to the economics if people are willing to pay to go out to
we have this kind. Yeah, we have this kind of activities taking in Sweden. Many people like to fish and go out and fish. Yeah.
Other questions?
Yeah. What is the extent of the? My understanding is that part of the Baltic major parts are sort of a dead zone. What is the consequence been in terms of fish, the fishing industry, etc.? And I guess what's behind my question is if you could do this sort of thing on a large enough scale, could you remove enough nitrogen and ultimately confirm that situation around?
Well, I mean, these things collecting algae, it's in the coastal zone, so you have to have a bit, the water bodies in the coastal zone and outside is different in a way. So it's more a positive effect in the coastal region, in an archipelago, for example. But as you say, in the Baltic Sea, in the middle of the Baltic Sea, there is a big dead zone area, exactly like it's in the Black Sea, for example. And now it seems that you have it in the Mexican Gulf too. And this is a more problematic situation because it's on a very big scale. So, but of course, everything, it's part of the problem, but it's also part of the problem because the Baltic Sea is an enclosed sea with not so much water exchange with the Atlantic, and that causes much of the stratification. And then you have a high salinity water on the bottom and low salinity on top, so there's a halocline there that is difficult to break. So it's not only a problem related to the eutrophication.
Other questions?
What other countries are engaging in similar efforts in Europe?
Like this? Yeah, there is a lot. Scotland at the Oban, SAMS, Scottish Association of Marine Science, they have these activities together with Ireland.
Funded by their local agencies?
Yes, and European Union. And then there is activities in Germany, and on the if you go into microalgae, it's big in Holland, for example. There have a big things taking place. And Norway, of course, have a lot of things happening here. And this is an emerging research field, the blue growth. It's just a couple of years old, and it's starting very rapidly
In
now.
this country?
Pardon me?
In this country, do you know?
Here in the US. I guess it's big here. I mean, microalgae research have been big here, but I think it's here also.
Yeah.
I think. I don't know so much.
A big push in the United States for algae-based fuels is the renewable fuel standard. Is there something like that in Sweden that covers sea algae-based fuels?
Yeah, no, we don't have any subsidize on this. And in Sweden, we are more biogas because it's kind of easy. We have cars on biogas and we have infrastructure already for biogas. So the interest have been very much focused on biogas. Before it's been ethanol that have been subsidized a little bit with the carbon dioxide tax, you could say. And there have been some extra premium if you buy one of these cars that doesn't release so much carbon dioxide, you get a premium from the government, so you could buy a car. But we don't have a direct subsidize on the fuel itself.
And there's no requirement that the fuel contain a certain amount?
No, there is a certain amount in diesel and gasoline. You could mix in gasoline, you could put in ethanol, for example, and things like that. That have been.
Any other questions? Okay, thank you again.
Thank you.